Time we completed Kepler's laws from gravitation. Now the next point is uniform circular motion and uniform circular motion. And magnitude of centripetal force. Today we will learn these 2 points. Now see what is mean by uniform circular motion. All of you know, when any object moves in a circular path constantly because of one force acting at the center, that force is called as a centripetal force. Last time we seen about the centripetal force, how it acts on the object and how object can move in a circular path. Now suppose we will take any one object which is having the mass m is the mass of object. Suppose v is the velocity or speed of that object, and r is the distance. Now suppose r is the distance. Distance means, that is, we will say that radius from the center. All of you know, from the center up to that circumference, we will say that this distance called as a radius. Then how can we write the formula of centripetal force? F is equal to, all of you see, F is equal to mv square upon r. This is the general formula for the centripetal force. But all of you know, v means speed. Speed, the formula of speed is distance traveled. When we have to calculate the speed, then how we will calculate? Distance traveled by any object in given time, means distance upon time. V is equal to distance upon time. This is also, we can say that speed is equal to distance upon time. Now V, distance upon time. Suppose this is the circle. Here I am drawing one circle. This is the circumference. When any object is moving in this path, then the distance traveled is called as a, we will take circumference. So V is equal to 2 pi r. All of you know the circumference is 2 pi r and divided by time means t. So V is equal to 2 pi r upon t. Now our main formula is this one. Suppose we will put the value of V in this place, then how we can write? F is equal to m 2 pi r upon t square divided by r. Next, F is equal to m into bracket. Suppose square of 2 is 4, pi square, r square divided by t square and upon r. Now here I am writing, see, we get F is equal to 4 pi square r square m divided by t square upon r. Now next page I will continue this derivation. Now we get F is equal to m into bracket 4 pi square r square divided by t square and again divided by r. When these are again dividing by r, how we will write this for this step? 4 pi square r square m divided by t square into 1 upon r. Now all of you know the r, here 1 r is there and here 2 r. 1 r will be cancelled and 1 r remain here, means we will get this r cancelled from this 1 r. Then 4 pi square rm divided by t square. Now by multiplying and dividing, by multiplying and dividing by r square, denominator as well as numerator, which formula we will get? See, 4 pi square rm into r square divided by t square into r square. What we will say here? By multiplying and dividing by r square, or dividing, means here multiplying or dividing to both these steps. So here we multiply. Now what we will get? See here, 4 pi square r cube m divided by t square r square. Now see, here all of you know, according to the Kepler's third law, t square upon r cube, t square upon r cube is equal to k. Here we remove r cube divided by t square outside this bracket, then we will get 4 pi square m upon r square. According to Kepler's law, t square upon r cube is equal to k, means it is a constant. Now suppose, how we will write then? Here is a r cube upon t square, exactly opposite to k. So r cube upon t square means what? Here r cube upon t square is equal to 1 upon k. By putting this 1 upon k into our formula, what we will get? See, 1 upon k into bracket 4 pi square m upon r square. So here f is equal to, our final is, derivation is 1, f is equal to, means force is equal to, which force? Centripetal force. 1 upon k. Instead of writing 1 upon k, we will write here 4 pi square m upon r square k. So this is our final equation. Now from this equation, Newton concluded that force acting on any object or a planet for circular motion is inversely proportional to the distance, square of the distance. R means distance. So force is inversely proportional to the square distance between the planet and sun. So here today we finish the derivation of centripetal force.